So now we're going to talk about properties of the logarithmic and exponential graphs. So 2 to the x, I'm just going to graph these in. 2 to the 0 is 1, 2 to the first is 2, 2 to the second is 4. We know we have this little, approaching 0 on this side. And I just want this to be a little bit more accurate. This point up here, the next one, 2 to the third is 8. So this is my 2 to the x, and then my log base 2 of x, right? We switch the x's and y's. It bends this way. Okay, and that's my graph. I am at a smartboard where I can't really see much of it, so I'm actually going to zoom so that we can see more of the page. It's a little too much. Let's try 100%. Okay, so that looks good. Just because of the aspect ratio of my graph. This isn't like a shorter tail or anything. It's just kind of like the window I have on my graph. So first off, we're going to do the red values, the domain of 2 to the x. It goes forever in both directions, back and forth. So this is negative infinity to infinity. Or we could say x is an element of the reals. That's another way to write that. You might see either of those. I'm just going to keep the one, but realize you could write it that way. For the range, if I go up the graph, there's nothing down by the negatives, and this graph also never touches the x-axis. So the range starts just after 0 and goes up to positive infinity, with a parentheses here, not a bracket. What point is always on a graph that is y equals b to the x? So no matter what number I put here, any base to the 0 always equals 1. So the common point is 0, 1. That point is always, unless we transform and move it around. If it's a parent function, it goes through that point. This is a new word. An asymptote is a line a graph can't cross. So no matter how far I go over in that direction, this graph never crosses the x-axis. Now the equation of the x-axis is y equals 0. So we call that an asymptote, and that's a word you would hear as you move on in pre-calc and calc, because there's other types of graphs that don't cross lines. End behavior. Okay, so looking at the left side of this red graph. So as x goes to negative infinity, right, we're going back towards negative infinity. Where is y going? Y is coming down towards that 0, right? Y is going towards 0. It never gets to 0, but it's heading towards 0. End behavior on the right side. So if we come on this side of the graph, right, it looks like x is going to infinity, right, over this way, and y is also going to infinity. So as x goes to infinity, y goes to infinity. So that's the right side of the graph there. So now we're going to look at all of those same properties for the log, see what's the same, see what's different. So if I talk about my domain for the log graph, now my x values never become negative, and they never actually touch the y-axis either. So now this is 0 to infinity for the domain. The range, this arrow goes down forever, and I know it's going up really slow, but it is going up slightly forever. So its domain, or range, sorry, is negative infinity to infinity. And this should make sense. These are inverses. We switched x and y, so their domain and range switched. What point is included, right? Once again, because it's the inverse, instead of having the point 0, 1, this has the point 1, 0. The asymptote, now it can't cross the y-axis. And the y-axis has the equation of x equals 0. That's the line it can't cross. And then end behavior. So looking on the left side of this graph, okay, we can't say it's going towards negative infinity because it can't cross 0. So what we would say is as x goes to 0, okay, and to 0 from the right. So we're going to the left from the right. So on this side is the right, you're on the right side of the y-axis is what that means. We would say that y is going way down, right? So y is going to negative infinity on this side. To do our end behavior on the right side, so now we're talking about this side, right? X definitely going towards positive infinity. Y ever so slowly, because it's not increasing very quickly, is also going towards positive infinity. Okay. So those are your qualities of your exponential and logarithmic parent functions. Just to add a little bit extra, no matter what base I use with those same rules of being greater than 0 and not equal to 1, the log graph would have these same qualities. It would be in slightly different points and stuff, but it would have those same basic qualities for the parent function.